hello, hello, Algebra 2. This is your Chapter 7 self-assessment, which we're going to go through on this video. This is a great tool to use to study for the upcoming test. And don't forget your Learning Target packet as well is a great resource. Between the two of these, you should have all of your bases covered in order to score an incredible mark on the Chapter 7 test. Okay, so let's get started. The first number 1 and number 2 say to rewrite the equations in log form. So all of this is just training for solving later on. So we're going to go from exponential form to log form. This is log, and your base is 2, so that goes as the subscript. So that's the base of the exponent, is the base of the logarithm. Logs are always equal to the exponent. That exponent is 5, so the 32 fits right here. And so this right here and this are equivalent expressions. One's in exponential form and one is in logarithmic form. Okay, let's do the next one. Get my glasses on so I can see. So this is log and base of 1 over 3. 27 equals negative 3. Okay, now we're going to go the other direction. So we start at the base and we just go around the problem. Circle around the problem. 5 squared is equal to 25. Okay, and so what you write down should make sense. 5 squared is equal to 25. All right, and then ln of e, so you don't see a base here, but ln has a base of e, so this is e to the first equals e, which makes sense. E to the first equals e. All right, evaluate the following logarithms. So these are just expressions, so we're going to use the property that if you have a base of 2 here and a base of 2 here, they will just negate one another and equal out to 1. So I have to rewrite 16 as a base 2, and so that's 2 to the 4. Negate, the 4 drops, and this is 4. We've done tons of these problems, so this should make perfect 6. This one's already set up for us, 6. This is a log base 10. And we want to write 10 right here, so we got to think about 1 over 100. So 100 is 10 squared, so that's going to work, but it's in the denominator. So what kind of exponent do we use to put it in the numerator? A negative exponent. So this is negative 2, cancel, negative 2. All right, ln of e is just 1, so this 5 just drops. That one's done for us. The 2 just drops. And then here, this is the ln of 1, and this is kind of not one where we're trying to match bases. This is just one where you need to know anytime you have a 1 behind here, you know, if you were to set this equal to, you know, a variable, because, you know, it's unknown, just say it's unknown what this is, you would go e to the x equals 1. This is a base e. And the only thing that'll work there is 0. Anything to the 0 power is 1. So anytime you see a 1 right here, the answer is equal to 0 when you're dealing with a logarithm. All right, then we're going to condense, or expand and condense, go both ways. We do the condensing because that helps us solve when we get to kind of the last part of this chapter. All right, so to expand, I just want ln in each step here. All right, so I want the ln. I just want one thing behind it, a 5. All right, there's 5. Now I'll go to x squared. They're both in the numerator, so they're added. They're positive terms. But I don't want to write x squared here. That's 2 items behind the logarithm. And to have it fully expand, you can only have 1 item behind the logarithm. And when I say 1 item, nothing can be squared. You can't have anything being multiplied like 5x. So I have to deal this 2, and since it's a power, it just comes right, I'm going to give myself some space here, it comes right in front. Okay, so this x squared expands to 2 ln x, and then the next term is in the denominator, so that's a minus, and that's just minus ln of 2. So that's how you expand. This blank we don't need. And then in the next one we condense, we go the other direction. So we want everything behind the logarithm. So likewise here, the 2 will come back up in exponential position. This will mean multiplication. Okay, y is just y, z is just z, and this will mean division, meaning in the denominator. So this will be x squared times y over z. Okay, the next ones we're going to solve. And so there's lots of different methods to solving. This first method would be like bases. That's the method I'm going to use here, like bases. All right, so we're going to write this as 2x plus 3, and we're going to write 16 as 2 to the 4. All right, so basically with like bases, if 2 is raised to a power and it equals 2 raised to a power, those two powers must be equal for this equation to hold. So you can just kind of ignore the bases and work in exponential position. And so here x is equal to 1. Same thing here. I'm going to write this as base 3, but it's 1/3, so I'm going to be moving the 3 up. I'll make it uncomfortable, so it gets a negative exponent. Okay, and then this is base 3, so that's good. So I'm just going to multiply these two because that's a power to power. So negative x equals, and you can ignore the 3 because those are the same base. So negative x equals x minus 6 minus x minus x. So minus 2x equals negative 6. Divide by negative 2. Divide by negative 2. X equals 3. Okay. So back page here. Some more solving strategy that I might use here is to circle around. Let me straighten this up. I'm not looking at it sideways. Circle around the problem. Sorry, it's my calculus stuff underneath here. X squared equals 36. Okay, and if you were to square root both sides, you would get x equals plus or minus 6, okay, but we're not going to have a negative base, so we only give x equals to 6. All right, here, 3x, e to the 3x, let's divide 3 on both sides. Okay, so I'm just dividing, that was, there's that step. So I'm just saying e to the 3x equals 3, all right? And so I need to pull this 3x down so I can solve for it. And what I'm going to use is ln, because it's the inverse of e. And I'm just going to take the ln of both sides. That's going to pull the 3x down, have it equal to the ln of 3, and then divide by 3. So this is x equals ln of 3 over 3. Okay, so let's see. It didn't really say to put things in decimal form, so I'll just have that in exact form there, but you could always go to the decimal form on your calculator. All right, let me actually pause and go get my calculator so we can see that. Okay, I got my calculator. Calculators are allowed on the test, so if you have to compute, I want to make sure we go through that. So ln of 3 divided by 3, okay? And so as a decimal, that's just 0.37. I'll just round 2 places, 0.37. All right, next problem. Same thing here. I need to pull this down. This time I'm going to use log. You could use ln if you like, but typically log's kind of the go-to. It 100% doesn't matter. You can use ln if you like. All right, so this is a team up here. That's a binomial. That's a team. So I'm going to put parentheses around it as it comes down to keep it as a team. Okay, so just applying a log to both sides just pulls that down in front. Okay, so now I'm going to divide out that log 3 on both sides. I have a lot of room here. And x plus 2 will just be on this other side. So divide by log 3 and log 14 divided by log 3. All right, so that is gone. And I don't need the parentheses anymore. It's just x plus 2 is now grouped on a side by itself. All right, now I can pull the 2 away, minus 2, and go to decimal here. All right, so this will be log 14 divided by log 3, enter, minus 2, enter. So this is 0.402. Or if we're rounding to the hundredths, we would just say x equals 0.4. Okay? Number 18, so just, kind of focusing in here. This is a strategy where if I have a log on both sides, it's kind of like when you have the same base on both sides, how you can just ignore the base right here. Okay, same thing as if you have the same log on both sides, we can just ignore it. So I'm going to ignore this log, and then just solve for the exponential. So x squared plus x equal to 12. All right, so that's solving right here. This is a quadratic. So set it equal to 0. Factor. And we get x is equal to -4 or x is equal to 3. So I need to check and see if those cause a problem behind the logarithm. So 12 doesn't, there's nowhere to plug in there, so let's check. So if I do -4 in here, I'll get -4 squared, which is 16, and 16 minus 4 is 12. So even though this is negative, it does not cause a problem. So that is still a solution, a valid solution. And 3 is 2. That'll be 9 plus 3, which is 12. So this is maybe the first time we've seen two solutions working, and that's okay. So it's good to see that. All right, and then this one here is an example where you don't have the log on both sides. So this is one where we condense and circle, okay? So this one we would have condensed if we had needed to, but we didn't need to. It was already a single log on both sides. This one we need to condense, and so this 3x will be times this 2x as a single log, and then equal to 9. So in this one we're going to circle around the problem. We're going to say e to the 9 equals all of this here. This argument is what that's called, the component or the argument of the logarithm. And this is 6x squared. Okay, and so then divide both sides by 6. E to the 9th over 6 is x squared. Okay, and then I'm going to take the square root of that. Okay, so plus or minus, but I'm not going to need the minus here because any negative number would make this negative and this negative. So I really don't need the negative there. I'm just going to give the positive answer. All right, so let's do that. The square root of, and know your calculator, and whatever you're using, know how yours works for you, because they're all different. So sometimes you have to do things in a different order than I do on the TI. All right, so I've got the square root of e to the 9th. I'm going to close that parentheses. Whoops, there we go. And divided by 6. So I'm looking at the screen here. So I've got the square root parentheses of e to the 9th in parentheses, that closes the exponent, divided by 6. And now I'm going to end the parentheses of the square root. Enter. And we get 36.75. Okay, so this would be 36.75. Okay, so, I always like to check if you have time on the test. Why not check? Let's just see if this works. The natural log of 3 times 36.75 is equal to, plus, let's add plus, the ln of 2 times 36.75. Make sure I have that right. I can see it actually better on the screen. It's really dark over here from my vantage point, but I can see that on the screen. So that looks good. Let's close that and see if it equals 9, and it does, so I can feel confident in my answer there. So. All right, some word problems. You deposit $1,000 in an account that pays 7.3 annual interest compounded monthly. How much we have after 15 years. So all of this is important information, as is picking the right formula. And so I'm going to go sneak a peek at the test real quick so I can speak to what formulas are on there. So I'm going to pause for a second. Okay, I'm super glad I did that because the formulas are not given to you on the test. So you're going to want to, I'm just kidding. They are on the test, but they do look a little bit different. So on the test you will see this formula, okay? And so this is for compounding. This one is for continuous. compounding. And then you won't see these two, okay? You won't see these two on the test. Instead, you'll see the general form of this, which is A and then times B to the T, okay? Because this is just B with a percent growth, right? You just take, like if it's a 5% growth, you just say 1.05. And this right here is B if you have a percent decay or decline. So decay. All right. So if the population is decreasing 5% a year, you would use 1 minus 0.05. So you'd use 0.95. So on the test, you'll see this, this, and this. Okay. Because this kind of accounts for those two. All right. So on 20, you deposit 1,000. Okay. So I've already read that. So when you read compounded and monthly, you go to this formula. You go to A equals P 1 plus R over N to the NT. All right, so we're looking at an amount. Our P is what we start with. We start with $1,000. 1 is set in the formula. Our rate, please don't use 7.3 or 0.73. You want to make sure you push that decimal 2 places to the left, so that's 0.073. N means for the number of times it's compounded. So N means the number of times it's compounded. So monthly would be 12. And then you raise it to the 12, and we're looking at 15 years. Okay, so it's my recommendation on the scientific calculators to put it in like so. Here we go. I would do one, or actually I would even go this far as to go 0.073 divided by 12, enter. Plus 1, enter. Raise to the, and you could multiply those first, 12 times 15 first and have that number, or put these in parentheses. But if your calculator doesn't have parentheses, then I would multiply 12 times 15 first and then raise it to that particular number. Okay, so there's that, and then we multiply finally by 1,000. Now, it should make sense, okay? It should be a reasonable number. So your money is growing, and it's 15 years. That's quite a long time. And, 7% interest rate is fairly good. So that makes sense that you would, have grown that much. So if you have a TI, you can just straight do 1,000, parentheses 1 plus 0.073 divided by 12, 2. Now you still want these in parentheses, whoops, times 12. Okay, you can put it in just like that. 1,000 times 1 plus 0.073 divided by 12 raised to the end parentheses 15 times 12. And there you go, $2,979.28. Okay, the next one, the value of a new car purchases decreases. There's a decrease by 12% per year. Write an exponential model for the value of the car and use the model to estimate the value. So this is a general. This is not a compounded. So we don't use our compounding. We're just going to say, we can use Y equals the car value at the start of this problem, and it is decreasing by 12%. So we're going to say 1 minus 0.12 is going to be our base, our multiplier here. So basically this just says you're keeping 88% of your car's worth per year. And then we just put 5 up there. Okay? So 28,000.88. How much is this car worth after 5 years? So this number should make sense. It should be going down in value. Okay? So you purchased it for 28,000, and after 5 years it's only worth 14,776.49. Okay, that answer makes sense to me. If you get a negative answer or a number that's bigger, if it doesn't have a reasonableness to it, then you want to maybe see if you put something into your calculator that's not correct. Okay, next one, last one. This is the key word, compounded continuously. That's where we go to our PERT formula. Okay, so you put $5,000 in an account that pays 3% annual interest, compounded continuously. How long to the nearest year would it take to double your money? So if we put 5,000 in, then I want 10,000. I want to double my money. E is just E, and rate is 0.03, and time is time. So since I'm solving for t in the exponential position, I need a log. And since E is in the formula, I'm going to need ln. All right, so we're going to divide by 5,000. And that's going to be 2 equals e to the 0.03t. I'm going to ln both sides, which will pull the exponent down, and ln of e will just cancel. And so this is ln of 2 equals 0.03t, and we're just going to divide by 0.03. All right, so ln of 2 divided by 0.03. Okay, ln of 2 divided by 0.03, and whoops, there we go. So, how long to the nearest year would it take to double your money? About 23 years. All right, 23 years. Don't forget your units. Okay, you guys, good luck studying again, LTQ and this, and I will see you tomorrow or Wednesday for the big Chapter 7 test. All right, bye.